Welcome, everyone. I'm excited to kick off today's presentation on database management and platform security. Today, we'll focus on application and access control. We'll explore key concepts and best practices to keep our data safe and secure. So, let's get started and dive into how we can effectively manage databases and ensure platform security. Today, I want to talk about how application and access control are essential for protecting our data. First, it ensures data confidentiality, integrity, and availability. In simple terms, it keeps our data private, accurate, and accessible when needed. Next, it helps define who can access our data and what they can do with it. This means setting clear permissions so that only authorized users can perform specific actions. It also plays a critical role in securing our enterprise-level platforms and applications, acting as a barrier against potential threats. By preventing unauthorized access and data misuse, access control helps us avoid security breaches and data leaks. And importantly, it supports compliance with security policies and standards, ensuring we meet regulatory requirements. Overall, application and access control are key to safeguarding our information and maintaining trust in our systems. Let's talk about application security, which is a crucial aspect of protecting our digital assets. First, it's about protecting application data and logic, ensuring that sensitive information and core functionalities stay safe from malicious actors. This involves safeguarding both the data stored within the application and the way the application processes and handles that data. Next, preventing unauthorized access is key. We need to make sure that only the right people or systems can access certain features or information. This is about implementing strong authentication and authorization measures so that we can control who gets in and what they can do. Another vital point is ensuring data confidentiality and integrity. Confidentiality means keeping information private and only accessible to authorized users, while integrity involves protecting data from being altered or tampered with. Both are essential to maintain trust and accuracy in our applications. Finally, adopting secure development practices is fundamental. Building security into our development process helps us identify and fix vulnerabilities early on, reducing risks down the line. Overall, application security is about creating a robust defense that safeguards our applications from threats at every stage. Let's take a closer look at users, roles, and groups. Users are the individual people who interact with the system. Each user has specific needs and responsibilities. Roles, on the other hand, are the permissions assigned to these users, defining what they can and cannot do within the system. Groups are collections of users who share common roles, making it easier to manage access for multiple people at once. This leads us to the core concept of role-based access control, or RBAC. RBAC simplifies security management by assigning permissions based on roles rather than individual users, ensuring that users have appropriate access according to their responsibilities. Understanding this structure helps us create a more secure and efficient system overall. Let's dive into roles and role management. This is all about how we assign specific roles to users and groups within our system. By doing this, we ensure that the right people have the right access to perform their tasks effectively. One key concept here is role inheritance, which allows roles to cascade or pass down permissions, simplifying management. For example, if a user is part of a group, they automatically get the permissions assigned to that group. Now, we also have standard roles like admin or ITIL, which are predefined to streamline setup and ensure consistency. Using these standard roles helps us avoid reinventing the wheel and maintains a solid security framework. Finally, I want to emphasize best practices for role design, keeping roles simple, focused, and aligned with organizational needs, so we can maintain both security and flexibility. All these points tie back to our overall goal, managing access efficiently while safeguarding our environment. Let's start by understanding what ACL controls actually do. They regulate access to various parts of a database by specifying permissions for tables, records, and fields. This means we can control who sees what and who can make changes, which is crucial for maintaining data security. Now, an ACL, or access control list, is essentially a list of permissions attached to each element within the database. It helps us define exactly what each user or role is allowed to do, whether it's reading data, modifying records, or updating specific fields. The importance of ACLs in data security cannot be overstated. They serve as a gatekeeper, preventing unauthorized access and ensuring that sensitive information remains protected. By implementing proper ACLs, we can significantly reduce the risk of data breaches and ensure compliance with security policies. In the context of our overall presentation, understanding ACLs is fundamental because they form the backbone of how we enforce security measures at different levels, be it tables, individual records, or specific fields. This layered approach helps us create a robust security framework for our data. Now, let's take a closer look at the different types of ACLs, or access control lists, that we might encounter. At the broadest level, we have table-level ACLs, which control access to entire tables. Moving a bit more granular, we have record-level ACLs, which specify permissions for individual records within a table. And even more detailed are field-level ACLs, where we define access rights for specific fields or columns in a record. When it comes to operations, ACLs generally specify what actions are allowed or denied. These include reading data, writing or modifying it, creating new records, or deleting existing ones. Each of these operation types can be controlled through different ACL configurations, depending on the level of security or flexibility needed. The key takeaway here is that ACLs offer a layered approach to access control, allowing organizations to tailor permissions very precisely, whether at the table, record, or field level. This granularity is essential for maintaining data security while ensuring users can still perform their necessary tasks. Throughout this presentation, we'll see how choosing the right ACL type helps reinforce our overall security strategy. Let's take a closer look at application scope and security. First, we have to understand the difference between global and scoped applications. Global applications are accessible across the entire platform, while scoped applications are limited to specific areas or functionalities. This distinction is crucial for maintaining control and ensuring security. Next, restricting cross-application access is vital. It helps prevent unauthorized data sharing or actions between applications that shouldn't interact, reducing potential security risks. Protecting custom applications is also a key point. Custom apps often handle sensitive data, so implementing robust security measures is essential to keep that data safe from breaches or misuse. Finally, scope-level security rules allow us to define precise access controls. These rules specify who can do what within a particular scope, giving us granular control over permissions and enhancing overall security. All these concepts tie back to our goal of creating a secure, well-managed platform environment, making sure each application and user interacts only within their authorized boundaries. Let's talk about some important security best practices to keep our systems safe. First, the principle of least privilege is key. It means giving users only the access they absolutely need to do their jobs. This minimizes the risk if an account gets compromised. Next, it's crucial to avoid unnecessary admin roles. Only assign admin privileges when it's truly necessary, and regularly review these roles to prevent privilege creep. Instead of granting direct user access, consider using roles. Roles are easier to manage and help ensure consistent permissions across users. Performing regular audits is another vital practice. By reviewing access logs and permissions periodically, we can catch any anomalies early and maintain a secure environment. Finally, always test your configurations and changes before deploying them live. This step helps prevent unexpected issues that could introduce vulnerabilities. Together, these practices form a strong foundation for security, aligning with our overall goal of safeguarding our systems and data effectively. Access control is really the backbone of secure data handling in any system. It ensures that only authorized users can access sensitive information, helping us protect our data from breaches. Access control lists, or ACLs, play a key role here by providing protections at multiple levels, whether it's at the file, database, or application level. This layered approach makes our security more robust. Roles are another critical aspect. They help us manage user permissions efficiently. Instead of assigning permissions individually, we define roles based on job functions, which simplifies administration and reduces errors. This way, users get the right level of access quickly and consistently. Ultimately, implementing effective access control is essential for building secure and scalable applications. It's not just about protecting data now, but also about making sure our systems can grow and evolve securely over time. So, in conclusion, access control, ACLs, and roles are fundamental to maintaining security while supporting growth, something that ties all these concepts together and aligns with the overall theme of building reliable, secure systems.